In this video lecture, I would like to discuss higher order linear equations with constant coefficients. So in the previous topics, we learned how to solve second order linear equations. But here, we'll look at higher order, meaning that we could have third derivative, fourth derivative, etc. So we are interested in solving equation of the following form. A sub n and the nth derivative of y plus a sub n minus 1 and the nth minus 1 derivative, etc. up to a1 times y prime plus a0 times y equals to g of x. So we are looking at non-homogeneous equation. Here, the coefficients a sub n is n minus 1, etc. a1, a0 are constant. And we use this notation to denote the nth derivative. Or if we have third derivative, then we may use y triple prime. For derivative, we could do that as well, but for higher derivative, it is easier to use the notation here. So as for second order differential equations, the general solution has the form y equals to c1 y1 plus c2 y2 plus, because we have nth derivative in the equation, we will need n solution. So cn times yn plus capital Yx as before, where the y1, y2, etc., yn form a basis for the space of solutions to the corresponding homogeneous equation. We have an nth derivative, etc. up to a1 first derivative, a0 times y equals 0. This is the corresponding homogeneous equation. We need to find y1, y2 up to yn. And then for the second component in the solution right here, capital Y, as before, is a particular solution to the non-homogeneous equation. We will try to find capital Yx by using undetermined coefficients. It's possible to use variation of parameters and also reduction of order. However, those methods would be more complicated when we have higher derivative. So we will only focus on undetermined coefficients in this topic. Now, in order to solve for y1, y2, yn from the homogeneous equation, we do as before. We need to solve the characteristic equation. An and then nth derivative will give us r to the n, etc. A1 first derivative will give us r plus a0 equals 0. So how do we determine those solutions? Um, the method is the same as in second order. If r equal to say alpha is a root, then we get e to the alpha x. If we have a complex root, actually when we have complex root, we will have a pair plus or alpha plus or minus beta I. Then we have a pair like e to the alpha x cosine beta x, then e to the alpha x sine beta x. And if we have repeated root, if a root repeats, then we just multiply the solution by x. Multiply. So for example, if above, if alpha is a root, then we get at the beginning e to the alpha x. But then if we have another alpha as a root, then the second solution would be x e to the alpha x. And if we have another alpha after that, then the next solution would be x squared e to the alpha x. And we keep doing that for repeated root. And for capital Y, we also do as we did for second order. We have a initial guess, and then if initial guess is a constant times y1 or y2 or y3, then we need to modify the guess by multiplying by x. So let's look at a few examples here. Example 1, we want to solve the non-homogeneous equation y double y triple prime minus y double prime equals to 3x. This is our non-homogeneous equation. Now the equation here is of order 3 because we have y triple prime, meaning that we need to find y1, y2, y3. 1, 2, y3. Solution for the corresponding homogeneous equation. And the homogeneous equation is 4y triple prime minus y double prime equals 0. So to find those solutions, we have characteristic equation. Before the third derivative gives us r cubed. The second derivative gives us r squared. And then we have 0. Now we need to know how to solve certain equation for r. It turns out that in general it will be difficult or even impossible to solve an equation for r. But in this topic, we will see a few types of equations. And whenever you are given an equation and you want to solve for r, the first thing you try is to use direct factoring. Try to see if all the terms on the left side could be factored. This is called direct factoring if possible. And in fact, we can do that here because r squared is a common factor. We factor it out. then we get 4 minus 1 left equals 0. Now when we solve for r, we also want to know how many times a root repeat. So for this r squared, I will split it as r times r. So I make into simple factor here. And now I solve, I will have the first one will give us r equals 0. The second one give another 0. And the last one will give us 4r minus 1 equals 0, which means that r is a quarter. Now we may label r0, r1, r2, r3. We have 3 values of r. And so y1 will be e to the 0x, which is 1. This is a repeated root. The second 0 is repeated. We won't be able to take the same term here. So instead, we need to multiply by x. X times 1 is x. That's y2. And then y3 is a new root. We have e to the a quarter of x. We have solved the homogeneous equation to get 3 solutions like this. Now next, we need to guess and find capital Yx. So let's recall from above that the homogeneous equation, our gx is 3x, is a polynomial. We begin with the first power of x. As in previous topic, whenever we have polynomial, we should rewrite in the full format. We should fill in all the missing power if needed. So 3x, we should rewrite as 3x plus 0. And once we have this, we will have initial guess. Capital Y is a times x plus b times 1. The 0 here is actually the coefficient. 0 times the constant 1 here. We need to make it clear. This is 3 times x plus 0 times 1, and that's why the initial guess. However, if you look at the initial guess, we have a times x, b times 1. This 1 here is actually the same as y1. And this is same as y2 as well. So whenever we have something the same as y1, we need to modify. I guess by multiplying the x, so we should have ax squared plus bx. Now when we have second order, we rarely need to modify again. But it turns out if you look for these two, x squared is not the same as one of these solutions, but x turns out to be same as y2. So we need to modify again. Here we need to modify by multiplying by x, we get bx squared. And of course, as in the previous topic, when we multiply this by x, we need to do the same thing here. Have domino effect. Otherwise, we would have the same term, right? So we should have a times x cubed. And now the new guess will work because x cubed and x squared do not appear as y1, y2, or y3. So once we know this, we need to take the derivative. This will be a little bit longer because we have more derivative to do. To take first derivative is 3ax squared plus 2bx. Second derivative is 6ax plus 2b. And then the third derivative as well, we have 6a. Now we plug into the non-homogeneous equation. Which says that 4y triple prime minus y double prime equal to 3x. I need 4 times the third derivative, which is 6a, minus the second derivative in parentheses because it has several terms. So 6ax plus 2b equal to 3x. And that's before. We should have 3x plus 0. We fill in all the orders of all the powers of x. And if it's mixing, we use 0. Now we distribute and collect like terms. And we write the terms with x first. So minus 6ax and plus here 24a minus 2b without x equal to 3x plus 0. Now we equate the coefficients. Then we get minus 6a is 3, which we solve for a and get minus a half. And then 24a minus 2b equals 0, which give us 24 times negative a half minus 2b equals 0. From here, we solve for b, we get negative 6, I believe. And so, capital Yx, we need to use the correct format that we begin with right here. So ax cubed plus bx squared. A is a negative a half, with minus a half, x cubed, and minus 6x squared. And then we have our final answer here. That's our y is c1, y1. Recall that y1 is just 1. And c2, y2, which is x, plus c3, y3, e to the quarter of x, plus capital Y, which is minus a half, x cubed, minus 6, x squared. This is the solution to the general solution to our ODE. So we have seen the method of direct factoring. In the second example, we have another problem which requires a different method to factor. So we are interested in solving the following ODE. Y triple prime minus 2y double prime plus y prime minus 2y equals to 2a to the 2x. This is our non-homogeneous equation. So first, we want to solve for, again, we have a third order. We want to solve for y1, y2, y3 from the corresponding homogeneous equation. And we can just write out the characteristic equation. R cubed minus 2r squared plus r minus 2 equals 0. So this time we have a different type of equation for r. As before, we will try to do direct factoring, but by looking at the four terms, we don't see any common factor. But for this problem, for this equation, we can use something called factor by grouping. We group the first two terms like this and the last two terms like that, and try to factor out the common factor from the first two terms and factor out the common factor from the last two terms. Now, for the first one, we have r cubed and then minus 2r squared. So common factor is r squared. Let's factor it out. And we have r minus 2 left. The last one, we don't have any common factor to factor out. Now, if we have a minus in front, we should factor that out as well, but we don't have any. So let's just group them like this. But it turns out, after we group the first two terms and the last two terms, we see that r minus 2 is a common factor. We may factor that out. We get r minus 2. Then what left is r squared plus, now right here without any coefficient, it actually means 1 times. So r squared plus 1 is 0. Now we solve, we have r equal to 2. And for r squared plus 1, we solve as before. We have r squared equal to -1, and we take square root, a plus or minus. For root of -1, we get plus or minus I. So we have 3 roots to the given equation, 2 and plus or minus I. So from here, we can take y1 to be e to the 2x, and y2, y3 comes from the imaginary root right here, which is 0 plus or minus I. So because of 0 here, we don't have exponential. We only have sine, cosine. So cosine x and sine of x. Now the next step is to find capital Y x. Recall that in our problem, g of x is a constant multiple of 2x. 2 times e to the 2x. Constant multiple of e to the 2x. So our initial guess would be capital Yx equal to a times e to the 2x. And now we need to check whether we should modify or not. And if you look at this is, let's say, same as y1. So we need to modify by multiplying by x. We have a x e to the 2x. So our new guess is a times x to the 2x, and x to the 2x is not the same as y1 or 2 or 3. 2 or 3. So we don't modify anymore, and this guess will work. We need to take derivatives and plug into the non-homogeneous equation. Derivative, this is a product, so we need to use a product rule. And so on. So it's a little bit tedious to do. I'm gonna just write down um, the formula for the second derivative and the third derivative. So after using the product and the chain rule and collect like terms, we will have something like this: 4e to the 2x plus 4x e to the 2x, and then the third derivative, here we have 12e to the 2x plus 8x e to the 2x. Now we need to plug into the non-homogeneous equation. Which says that third derivative minus 2 second derivative plus first derivative minus 2y equal to 2e to the 2x. So the third derivative is above, which is a 12e to the 2x plus 8x e to the 2x minus 2 times second derivative, which is we have a here, and then 4 e to the 2x plus 4x e to the 2x plus the first derivative, which is a e to the 2x plus 2x e to the 2x, and lastly minus twice the function, which is ax e to the 2x. On the right hand side, we have 2e to the 2x. Now we need to do algebra, distributing 2a into here and simplify, collect like terms. You may pause the video and try yourself here, but it will get 5a e to the 2x on the left side, and on the right hand side we still have 2e to the 2x. Now we solve for a, cancel this and divide both sides by 5. We have a is 2/5, and so our capital Y-x is 2/5 of x e to the 2x. Now put everything together, we have our final answer. Y equal to C1 Y1, 8, which is e to the 2x, plus C2 Y2, which is cosine x, plus C3 Y3, which is sine x, plus capital Y-x, which is 2/5 x e to the 2x. Now, so far, we haven't seen any initial value problems. It's possible to solve initial value problems, but then because we have too many constants here, for example, for this problem, we have 3 constants. Solving for 3 constants would be more complicated. So because of that reason, we won't see any initial value problem in this topic. Now I want to discuss another example of how to solve equation. Um, how to solve equation for R. This is another type of equation. Solve the ODE y fourth. This means the fourth derivative. But keep this in mind. It's not y times y 4 times. No, it's a derivative of y 4 times. So pay attention to the parentheses around there. Minus 2y double prime minus 8y equals to 8x squared. This is our non-homogeneous equation. So as before, we begin by solving the homogeneous equation. And because we have 4 derivatives, we should expect to have 4 solutions, y1, y2, y3, and y4. The homogeneous equation has this form, and we have the characteristic equation as before. R to the fourth minus 2r squared minus 8 equals 0. This is an equation with r to the fourth, but we only see even exponents, even powers of r, only even power. So we call such an equation quadratic-like. Quadratic-like. The reason is we only have even powers of r, and also the reason it's called quadratic-like is that r to the 4 can be written as r squared, and then we have r squared minus 2 is the r squared minus 8 equals 0. So if we think of r squared as just a single quantity, then it has the quadratic format, because this quantity here square minus 2 times the quantity, and then minus 8 equals 0. So we might try to factor this. But when we factor, we will have the quantity, instead of r like before, like quadratic equation, we will have r squared and then r squared here. And we need to look for 2 numbers that we should put here to match the equation. So I think this will be minus 4 and plus 2. And you should double check, right? R squared times r squared, we have r to the 4th here, and then r squared times plus 2, so plus 2r squared minus 4r squared, we get minus 2r squared. And the last one, minus 4 times plus 2, we get minus 8. So that's good. We could factor this further to have r minus 2, r plus 2, and then r squared plus 2, we can't factor anymore. We get r equal to 2, r equal to negative 2, and here r squared equal to negative 2, we need to take square root, plus or minus square root of negative 2, which gives us I. So plus or minus square root of 2 times I. So y1 is e to the 2x, y2 e to the negative 2x, y3 and y4 come from the complex root here. Is of the form 0 plus or minus square root of 2 times I. So no exponential, but we have cosine and sine. So cosine of square root of 2x and sine of square root of 2 times x. Now we need to guess and find capital Yx. Recall that in our equation, gx is 8x squared. This is a polynomial beginning with the second power of x. So as before, we should fill in the missing powers of x. 8x squared plus 0x plus 0, like what we should do. And here 0 here means 0 times 1. So x squared, x to the power first, and x to the power 0. So our initial guess will be ax squared plus bx plus c, which means c times 1. Now let's look at these things. They are different from those y1, y2, y3, and y4. So not the same. Not the same as any of these things above. So we don't need to modify at all. Actually, we're not allowed to do so, because if we modify, we won't be able to solve. Once we know the format of y, can take the derivative and try to plug in the equations. For the derivative will be 2ax plus b. Second derivative 2a. Third derivative 0, and we need also fourth derivative with 0 as well. Now we plug into the non-homogeneous equation. Y fourth derivative minus 2y double prime minus 8y equal to 8x squared. And as before, we should have 0x plus 0 times 1, the constant. Let's use the derivative. The fourth derivative is 0 minus 2 times the second derivative above here, 2a, minus 8 times the function y is the full term, ax squared plus bx plus c. And on the right hand side, we have 8x squared plus 0x plus 0. Distribute and collect like terms. And let's rewrite the highest power of x first. So we have minus 8ax squared minus 8bx, and lastly the constant minus 4a minus 8c equals to 8x squared plus 0x plus 0. equate the coefficients, get minus 8a equals to 8. So a is -1. And next, minus 8b, the coefficient in front of x on the right hand side is 0. 0. We get b with 0. And lastly, minus 4a minus 8c is 0 as well. From here, we solve for c. We know that a is -1. So plug in here, we will get c is a half. So our capital Yx is ax squared, which means minus x squared plus bx, which is 0x. We don't need to write that. Plus c is a half. And the final answer is y equal to c1 y1, which is e to the 2x plus c2 y2 e to the minus 2x plus c3 y3, which is cosine of square root of 2x. Summarize the three methods that we have seen in order to solve for R. Direct factoring. Try this first, if possible. Second, we factor by grouping. And then the method of quadratic-like equation. Quadratic-like. Now this is another type of equation that we need to use long division or synthetic division, and I will discuss that in a different video.